Hello, welcome to lesson 3 in this subject of magnetism. My name is Mr. McQuire and today we will be studying series circuits. So you can see how this lesson fits into our learning journey through this particular topic. So before we get started, let's make sure we've got somewhere as quiet as possible and free from distractions. And you will need a pen and paper and ruler to write on. So I'll give you a minute just to get those sorted. So let's get going with our starter. First of all, at the top of your page, I'd like to put a heading of series circuit, top and center. And then we have got on the page in front of you 3 symbols here that we should know from the previous lessons, and then we've got 3 names, and you should be able to complete the picture of the symbols. So what I'd like you to do is to complete those. You've got a minute and a half in which to do that. Let's talk through those for a second. First of all, we have this one, an A in a circle, which is an ammeter for measuring current. So ammeters in the box. This is a bulb, and again, sometimes called a lamp. On here we have not a cell, but because there's more than one cell, we would call that a battery. A V in a circle, like the A in a circle here. A cell, which is a singular one of these, okay, with the positive and the negative, and then the switch 2 dots with it doesn't define the switch being open or closed, so it could be a line between the 2 dots or with the gate open. So here's our learning outcomes for today. For our challenge is to be able to build and draw series circuits, which is why you will need a ruler for today, and for our aspire is to be able to measure and predict the current in a series circuit. So in today's lesson you're going to be watching some practical work, and we're going to need to do some predicting as to what we think will happen. Let's get straight into our learning outcomes. Really, we're going to bundle them all together so that we're going to see some building, we're going to draw them, we're going to do some measuring and a bit of prediction, all in the time that it takes us to work through this slide that's here and watch the connected video that I put in. So the first thing I'd like you to do is to put the title down, investigating the effects of increasing the number of cells. Once you have done that, I'd then like you to put the results table down, which is on the right hand side of the presentation in front of you, and I'd like you to make it a decent size. 2 cells should be enough for this particular presentation, and you've got a minute and a half just to get those bits in place before we move on. Let's talk about how this particular section of the presentation will continue. You've got a title and you've got your results table. I'm now going to ask you to draw on paper step 1, which is a simple circuit with a single cell, 2 bulbs, and with an ammeter in series. Once we've done that, we'll then go through that particular diagram and make sure that it's correct, and I will put a clip in to show you that. And then we will construct the circuit as described by your circuit diagram and mine. And then finally, I'll do the experiment and we'll record the results in our results tables to make sure that we get everything in the correct order. So we are remembering that we are looking to see what the effects of increasing the number of cells is on the current in this particular. We're now going to move on to another one. We'll change the title from increasing the number of cells to increasing the number of bulbs. So what I would like you to do, again, as you did on that first investigation, I'd like you to put the title down and once again to draw the diagram of the results table that's on the right hand side of the page there. You've got a minute and a half to do that. So as we saw before, let's now watch the construction video. First of all, I'll draw the circuit diagram and you can correct yours. We'll watch the video and then we can get some results down in our results table as we move on and look at our predictions. So we've got one cell or battery, series circuit. Bulb or a lamp. And an ammeter. So that's the constructed diagram that we've been asked to draw. Now let's look at the practical work that goes with that. So I'm going to watch both of the video clips now and I'm going to look for two pieces of information. I'm going to look for the effect of increasing the number of batteries here from battery 1 to battery 2 on the current in amps, and then for a single battery I'm going to look for what the current is with one bulb but then with two bulbs, and then I'm going to do the same for two batteries with the second clip from a change of one bulb to two bulbs. So if you want to pause the presentation at this point, then I'm going to watch those two clips now to make sure that I've got some information to gather, and then I'll run through that. So here we have a battery which is connected in series to an ammeter. We've then got two bulbs which are connected in series, and at the moment the bulbs aren't lit. So let's put our complete circuit together. First thing I'm going to do is I am going to turn on the ammeter. At the moment the ammeter is reading through current that's flowing through two bulbs, and I'm now going to move so that we take one of the bulbs out of the circuit. You can see it's gone from 0.03 to 0.05. It's flashing slightly there. Now we've doubled the number of cells, and you can see that the current is 0.07 amps and that the single bulb is significantly brighter. If we now move it so that that single bulb is now two bulbs in series, you can see that both of the bulbs are dimmer. The current is higher than it was before but has still dropped. Let's look at the results we've got from those clips then. When there was a one cell here and one bulb, I saw 0.05 amps, and when there were two bulbs I saw 0.03, and then for two cells but with one bulb there was 0.07 amps, and when there were two cells or batteries there was 0.05 amps. So you can see that in both cases, as the number of bulbs increases, the current falls, and in both cases, as the number of cells increases, the current increases. Before we look at our plenaries together, let's look at our learning outcomes first of all. Now, it's obviously difficult to build circuits from the point of view of a video presentation, but we've been able to draw series circuits and measure and predict the current in a series circuit and the effect of putting additional cells and bulbs in there. Let's see what we've picked up as we've moved through the lesson. So here is a plenary question. First of all, Ben adds another identical bulb to the circuit in series. How does the brightness of the first bulb change? So you'll need to fill that in. And then we have a question that points backwards to the previous presentation in this series, and it asks how the brightness of the bulbs will change when the cells shown below are placed into Ben's circuit. So you'll need to think about how batteries should be used to be able to do that. What I'd like you to do is just to answer the three parts of those questions. We could call them 1, 2 and 3 in the minute and a half that you've got. So these are a good test of, first of all, today's learning, but also previous learning. First of all, adding another identical bulb to the circuit in the series. How does the brightness of the first bulb change? And the answer to that is that the bulb will get dimmer because the current is being shared between more than one bulb. And then the next part of the question, how will the brightness of the bulbs change when the cells shown below are placed into Ben's circuit? So you need to look very carefully at the circuit diagrams over here on the left. These are the right way round, so putting multiple bulbs together will increase the brightness of the bulbs, and that's your answer for this one. But when you look at this one, this additional cell has been added the wrong way round, so we've got plus minus and then minus plus as we look at the diagram. So therefore the cell will not light, it will go out, it will have no light, whatever those answers are that you would pick. Let's move on to the next plenary question. So here's the last part of our plenary today. Here is John, who has set up circuit E and is noting the reading on the ammeter. You can see that we have a straightforward series circuit with a bulb. It's a different symbol from the one that you've been using, and an ammeter and a cell. It then places another bulb in the circuit to make circuit F. He notes the ammeter reading in circuit F. So we're using today's learning. How will the ammeter reading in circuit F compare with that in circuit E? And can you explain your answer? So could you please answer that question now that we've got there, and we could call those part A and B. Okay, so let's have a look at our answers that we've got. So how will the ammeter reader in circuit F compare with that in circuit E? So the current will be lower in circuit F, and the reason that the current will be lower, to explain your answer, is because of the blockage or resistance that the additional bulbs are making to the flow of current is reducing the current in the circuit. So here we come to our learning outcomes at the end of today's presentation. First of all, for our challenge is to be able to build and draw series circuits, and we've certainly drawn them and you've seen some building of them. Hopefully you've predicted the builds as well. And then for the Aspire was to be able to measure and predict the current in a series circuit, and we've tried to do that today from the presentations that we have. My name is Mr. McGuire. Thank you for staying with this presentation today, and goodbye.